I gave this presentation a few weeks ago at a conference, and it's a rather long name for a conference. It was the 11th annual IEEE Information Technology, Electronics, and Mobile Communication Conference that typically takes place in Vancouver, but due to lockdown, it was virtual this year. Now, before I get launched into it, I'd like to pull up the abstract and essentially read the first few lines to just ground us. So, reading from the abstract, it has been said that the future of life is about artificial intelligence, and that as AI advances, a point will be reached, the singularity, when humans will no longer have a clue as to what is going on nor why. So that's the current paradigm and thinking about what artificial intelligence may lead to, essentially because with the computing power and the algorithms that are being developed, the thought is that that's going to far outstrip what any human being is capable of. And therefore, the singularity is going to occur where humans are not going to have a clue as to what's going on. Now, on the contrary, continuing to read from the abstract, this article will make the case that the future of life is enabled by the pre-existent complexity that exists in every iota of it. And this pre-existent complexity derives essentially from a multi-layered symmetry-based model of light, from which fundamental layers of matter and life, including the electromagnetic field, quantum particles, atoms, and cells, can be proposed to emerge. So this second point of view is in stark contrast to the current thinking about artificial intelligence. And that's essentially what this paper is focused on, is this stark contrast or this alternative view for what's possible in just the complexity that exists in life itself. And when we think about this, as I'll reach in a few minutes, it's going to set up some natural limits to artificial intelligence if in fact such a paradigm where you have pre-existent complexity deriving from a multi-layered symmetry-based model of light is true. So with that, let's launch into the presentation. And I'll mention also that this presentation, I received an award for Best Presenter, which was nice to do so. I've been presenting papers essentially to do with my work on light for the last few years. And just coincidentally, the last two presentations I gave for both of those, I received the Best Presenter Award, which was nice. So having said that, the way that this presentation is structured, it's in four parts. One is I'm going to introduce the model of light. Second, I'm going to show the kinds of emergences that happen in this computational model of light. Third, I'm going to go over some key points on contemporary AI. And fourth, just summarize the differences essentially between the computational model of light and the computational model as it exists in the contemporary thinking of artificial intelligence. So coming to the multi-layered symmetry-based model of light, what we see here is a matrix, and there's multiple rows in this matrix, but I'm going to focus at the top. So the top row here, essentially, we have a reality which I propose is light's native state, where light travels infinitely fast. And we see that this traveling of light infinitely fast creates four aspects or properties to that reality, which we just call presence, power, knowledge, harmony. But let me just elaborate so that we're grounded as to why that's the case. So imagine we have a volume of light, or a large volume rather, and at the center of that volume is a source of light. And imagine that you turn that light source on. Now, since it travels infinitely fast, it's going to fill up that volume instantaneously, so that light is going to be present everywhere. and therefore there's this property of presence. If anything not of the nature of light arises, then light's going to overpower it, so there's this property of power. Since everything is recorded in this fabric of light, whatever emerges, whatever disappears, light's going to have a knowledge of that volume and therefore the property of knowledge. And since everything exists in the fabric or nature of light, there's going to be an implicit harmony. So going back to this, essentially, we see that when light travels infinitely fast, there's this reality that's created that has these four properties of presence, power, knowledge, and harmony. Now, the second row you see here with the down arrow, that essentially signifies a quantization function, so that this subtle information that's depicted by presence, power, knowledge, harmony, when light projects itself at a slower speed that's depicted by the subscript k, which is lower than infinity, but still very, very, very high, then it's imagined that these four properties display or materialize into more of the richness of what each of them are. So we have the emergence of four sets, and these sets are a set of presence, a set of power, a set of knowledge, and a set of harmony. And you can imagine any one of these sets as having up to infinite number of elements that display the richness of that single property that we had called either presence, power, knowledge, or harmony. Now, in this subsequent row, there's another quantization that occurs, this RCN, and that further materializes this information that exists in sets in such a way that there's an infinite number of permutations and combinations in which unique combinations occur of the elements in each of the four sets to create, in fact, an infinite diversity of seeds. And so that's depicted by this line here, where c to the subscript n, where light travels at the speed n that's lower than k, but still above 186,000 miles per second. And the significance of this line is that essentially what it's proposing, that mathematically there's a couple of these quantization functions or transformations that occur that create infinite number of diverse seeds that, with a subsequent quantization or projection of light to the known speed of 186,000 miles per second, then create all the vast material diversity with its infinity of difference in this physical form that we recognize. So that's essentially what these layers of this matrix are saying. And then we have also a projection of light that where it exists at zero speed. So the reality would be the opposite of where it exists at infinity. And here, instead of presence, power, knowledge, harmony, we have darkness, weakness, inertia, and chaos. And this too has an influence due to some kind of quantization function on this physical layer, so that we can see, in fact, that there's a arbitration, a real-time arbitration, a persistent arbitration that's occurring at the quantum level, where there's many different influences from antecedent layers of light that are faster than the speed of light, 186,000 miles per second, and also from this layer of light where light's imagined to exist at zero speed. Now, whether this is true or not is not the point here. The point here is that there are different conceptual spaces that are set up in this model using the speed of light as a variable that allow us to think about what these conceptual spaces might look like. And mathematically, these conceptual spaces then allow us to construct all the infinite diversity that we experience here as matter, life, and as other emergences that are occurring and that will continue to occur. And that really is the power of this multi-layered symmetry-based model of light. It's symmetrical because if we look at it in a little more detail, we'll see that there are four properties that, of course, were proposed to exist where light travels infinitely fast. But then it's these same four properties that continue to create the reality even as light projects itself at different speeds. So there's a symmetry where we perceive these same four qualities from a different point of view. So they remain the same, but we're perceiving them differently, primarily because the speed of light is proposed to be different. And therefore, it's a multi-layered symmetry-based model of light. Now, there's consequences to this kind of conceptual space that I argue is, in fact, could very well be a reality and a single light-based edifice behind things. And in my point of view, the proof, or rather, the really, if what we see emerge in matter and life also has a fourfold reality that, in fact, can derive from this kind of persistent computation that's taking place, then there's a possibility that this model is a legitimate model for how things emerge at the material and life levels. So let's look at the emergences from this multi-layered symmetry-based computational model of light. So we can see here four different constructs. One is the field for the electromagnetic field. Then we have quantum particles, we have atoms and cells. But you'll notice right away, as you look at these, that the reality at each of these levels has the four properties that we saw that exist at light traveling infinitely fast of knowledge, power, presence, and harmony. And let's see specifically how this plays out at each of these levels. So starting with the electromagnetic field level, we can make the case that we know that the electromagnetic field is perceivable to us by the electromagnetic spectrum, and we have infinite variety of wavelengths and frequencies. And if we think about any wavelength or any frequency, then essentially a particular wavelength or a particular frequency gives rise to a particular kind of application and behavior. So, for example, we have radio waves, we've got microwaves, we've got ultraviolet, visible light, infrared, X-rays, gamma rays that are all different depictions or different emergences from that one field. But the point is that we can see that there's an archetype of a vast variety of possibilities that exist, and that's a function of essentially frequency and wavelength, or frequency or wavelength. And so that vast archetype gives us a glimpse into the aspect of knowledge, so light's property of knowledge that's materializing at the electromagnetic field through this array of possibilities, archetypal array of possibilities that shows up as frequencies or wavelengths. When we think about light's materialization as power, then we know that there's a correlation between the frequency of light and power, and there's a well-known formula where you multiply frequency by Planck's constant to arrive at the power that can be generated by a certain subspectrum of light. When we think about the light's materialization as harmony, then we can simply think about the constant speed of light that, in my perception, is intentional, and it being constant allows a lot of variety to arise in it, and therefore it creates the basis of harmony. And if we think about Einstein's famous equation equal to mc squared, and we substitute the E with the hv here, then essentially we have the mass potential that could be determined by a particular frequency in light. And so that gives us insight into how presence materializes in the electromagnetic spectrum. So we see that we have these four aspects that were proposed to exist, and that due to the persistent computational reality that's being arbitrated is going to create emergences that are architected by these four aspects of presence, power, knowledge, harmony. And we see this first such architecture that's cohesive, showing up at the electromagnetic field itself. Now, when we look at the quantum particles, which are a more advanced emergence in a manner of speaking, again, we see that light's properties of knowledge, power, presence, and harmony can be correlated or, in fact, materialized as what we call quarks, leptons, bosons, and Higgs bosons. So I'm going to give you one quick example here. When we think about quarks, we know that quarks uniquely makes up protons, and we know that the number of protons in a nucleus uniquely determines the atomic number of an element. And we know that the atomic number of an element uniquely determines the behavior of an element and what it stands for, therefore, its knowledge. And so we can see that knowledge is materializing as quark. So similarly, power materializes as leptons, harmony materializes as bosons. And as example, we know that bosons are required for any other essentially quantum particles to collaborate or to combine to create a greater wholes. And we know that presence is a function of the Higgs boson, or Higgs boson, in that sense, is a materialization of light's aspect of presence. When we look at another layer of complexity, a subsequent emergence from this multi-layered symmetry-based model of light, then we arrive at essentially the periodic table that has 108 known elements that exist in our universe. Many of these, or the latter part of this, perhaps around 15, 16, could be human-made, but certainly naturally occurring elements were 90 plus, 92, and 93. And interestingly, the periodic table itself is divided into four categories: the P shell, D shell, S shell, and F shell. But there's a correlation, and I'll make the case that it's light's aspect of knowledge that materializes as P shell elements, light's aspect of presence as D shell, light's aspect of power as S shell, and light's aspect of harmony as F shell. And to give you a couple of quick examples here, we know that, for example, in the P shell elements, we have silicon and carbon, silicon being the basis of computing machinery, carbon being the basis of life, and also, therefore, of the inherent intelligence or mentality that exists in life. And if we think about, for example, hydrogen and helium that are S shell elements, we know that they're responsible for a massive nuclear fusion that powers the suns, and therefore you can see that power is manifesting through these S shell elements. Now, if we move to this next layer of complexity of cells, any living cell, we find again that there's four molecular plans that animate any cell. These are nucleic acids, proteins, lipids, and polysaccharides. But if we ask what they function for, we can see that, in fact, nucleic acids is a materialization of light's aspect of knowledge. Proteins is a materialization of light's aspect of presence. Lipids, a materialization of light's aspect of harmony, and polysaccharides, a materialization of light's aspect of power. So the point being that this persistent quantum level arbitration is pushing to the surface more and more complex forms of matter in life that all maintain this architecture. And so when we look back at this model, we really have to pause and think, what it really is incredibly intelligent. And it's creating something that you can't really tell what it's going to create next. So the one commonality is that when we look at these emergences here, then we can see that there's richness, there's a subsequent richness. So for example, from this manifestation of knowledge, power, harmony, and presence to the manifestation in cells, we know, for example, like there are over 30,000 different proteins in the cell itself, which means that that set of presence has diversified and enriched itself. And so we can see that subsequent computation from this light-based model is pushing to the surface more and more richness that exists fundamentally in these properties of presence, power, knowledge, and harmony. And so here we have a quick depiction of this very complex, sophisticated, light-based computational model. And as we think about or contrast that with an artificial intelligence model and our contemporary thinking, there's a few things that stand out. One is that contemporary artificial intelligence is based on this notion of substrate independence, meaning that you can have any matter, and so long as that matter has multiple stable states so that it can emulate the process of memory, then it doesn't matter from contemporary AI's point of view what that chunk of matter is. So, yes, we use silicon right now to do computations and to essentially create stable states of memory. But I can make the case, if you look back at any of these emergences here, that each of these itself offers stable states so that memory can exist at the field level or at the quantum particle level or at the atom level or at the cell level. So this notion of substrate independence, what it's saying is that essentially it's severing us from the reality of light. And if I contrast it here, in the reality of light, due to some kind of innate intelligence in light, there's something in light that's pushing this fourfold architecture to more and more advanced levels. But in contemporary AI, if you sever it from this edifice of light, which is essentially the thinking right now because it's substrate independent, so it doesn't matter what the substrate is. Therefore, you're foregoing all that intelligence that exists in light, and therefore, any kind of AI that you create, by definition, can never be as intelligent as a light-based edifice from which all matter, life, and anything beyond it's going to emerge. Now, the other thing is that any matter, from the substrate independence point of view, any matter can be what's called computronium. So far as there are universal building blocks that can be combined to implement any function. So, for example, in computing technology, if you have AND gates and NAND gates and NOR gates and OR gates, then you can basically implement a whole variety of functions. But the point also is that when you look at these emergences here that arise from light, again, I could make the case that if we just think about the living cell, for instance, that there's a much richer kind of functionality that's enabled by universal building blocks. So if we probe into the life of proteins and the 30,000 different proteins that exist in a cell, there's such a complexity of building blocks from which functionality can be emulated that it's astounding when you compare it to the small set that we have that creates our current computing technology. So again, the point being that from light itself, there's a complexity that's arising that when we sever from that reality, then the kinds of conceptual and operational space that we create is by definition going to be limited. And that's the case with contemporary AI. So that's what this point is that by virtue of severing from the single light-based edifice from which everything arises, we've restricted conceptual and operational space, and therefore we'll be permuting and computing in a concise space only, and it can only have a set of results and not an infinite display of results. Further, when we think about the notion of intelligence in contemporary AI, then it's been said that essentially if you have a program that can duplicate what any human being, intelligent human being can do, or create something that required intelligence, then you have intelligence. Now, again, that's a very myopic, in my point of view, a myopic view of intelligence when you compare it to, for example, this light-based edifice where there's no bounds to what intelligence could be. But here you're severely bounding it, and you're giving the tag of intelligence to something that is just based on a few elements that exist in a limited conceptual and operational space. And so this final point here is that essentially contemporary AI is playing a finite game versus the light-based edifice is set up for an infinite game. And this essentially shows pretty starkly the contrast or the limits of what contemporary AI is set up to create or to be. So, in summary, a few points. Contemporary AI uses a substrate independent approach and therefore has a limited conceptual and operational space because it's fundamentally severing itself from a single light-based edifice in which all infinity exists. The kinds of emergences that happen in a light-based edifice, for example, matter, life, mind, display a completely different order of intelligence than what's possible in a limited conceptual and operational space. There's functional richness that's embedded in light that expresses itself in matter, life, mind, and anything else that might emerge. And as we consider each of these emergences of matter, life, mind, we see that this functional richness becomes much, 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 much more diverse. And there's an interesting final point that I want to make. So there was a book called Light 3.0 that's written by Max Tegmark. And this kind of, I think, summarizes some of the key arguments here. One, if we consider things from his point of view, or that's mainstream artificial intelligence, then he makes the case that you've got life 1.0, where hardware and software naturally evolved through eons. You got life 2.0, which is perhaps what we're in right now, where software is designed and hardware evolves. So hardware takes the eons long path. And you have life 3.0, where software and hardware are both designed. The point I want to make in summary is that, in fact, I believe that all of life is nothing but life 3.0 right from the very start, so long as we focused on this singular light-based edifice that animates everything and from which everything in this model arises.